staying on with the sustainability topic. I'm going to present, okay, my name is Josh, and I'm going to present a part of my PhD work, looking at the mobility patterns in the region and the sustainable mobility patterns in the region, and what kind of structure supports and affords those patterns. So we look at the mobility of the Randstad region, which is my case study, and briefly go over what this sustainable mobility is, as it is defined and how it is measured. Then present the model that I used to calculate those things, and then show some of the results and conclusions. So Randstad in the Netherlands, you might be familiar with. It's a region, a very well-known polycentric region, around 4 main cities: The Hague, Rotterdam, Utrecht and Amsterdam, with a big open thing in the middle, the green heart, which here is shown in green, and a very dense and integrated in the sense of being well-structured network of public transport with railways, trams, metro and motorways serving the whole region. And for this study I'm looking at all the neighborhoods as they are defined by 4-digit postcodes. You see these little black dots, they represent the neighborhoods of the region. And further on, my focus will be on specific neighborhoods that represent new towns of the region. Although I'm not going in this presentation to go into the detail of the new towns, but just discuss the overall results. So part of the study starts with the mobility survey that they do every year, at that the 4-digit postcode level. So this is just showing the aggregates of the journeys. So for the sample I have is 280,000 individual home-based journeys between those postcodes in the region, and so from that I have extracted. This is just a series of sustainable mobility indicators as they are. And so in the literature, so in terms of modal share for walking, cycling, and different distances of car travel and transit as well. And this is just I'm not going to go into any of the details, but just to give you an idea of the values and the profile of the Randstad as a whole, that actually has, as would be expected, a high percentage of cycle journeys, because it's the Netherlands. But also actually rather high percentage of walking journeys, so everything seems to look good in terms of sustainability, but still car journeys, especially for long distance and medium distance, still dominate in this. And surprisingly, given the public transport system that they have, the transit share is relatively small. For shorter, so for rail, long distance rail, there's actually 15% of journeys, but I still think that's quite small, smaller than would be desired. There's just some maps showing spatially those values at those points of the different neighborhoods. And as you can see, there's a clear spatial pattern. I mean, this is not random. It's clear where there's more walking and cycling happening in the city centers and less so in rural areas, as opposed to, for example, actually this is cycling, this is walking. So actually in the city centers also cycling, but cycling is also used on the edge of the city center more than walking. And again, for car and transit, there's less car use. The green means here less car use, of course, in city centers. There's a lot of transit use in city centers, etc. So we can extract all these patterns to get a picture of the region. And this is looking at those indicators in terms of the traditional city center and the transit-oriented developments, for example. And as you can see, the city center beats it's a thing apart. And as for the transit-oriented developments in green, they actually perform. They're transit-oriented, but their performance is very disappointing compared to the goals. So there's a lot of criticism of these developments and of the policy that led to them. that questions, but are they actually performing? Are they a failure? My argument is that these are like two different worlds. The traditional city centre and the transit-oriented development. You can't just measure, as I'm going to show next, measure certain simplistic things and hope that you can reconstruct the city centre performance elsewhere. There are reasons why the city centre performs differently. This is something I'll try to explore in my model. So sustainable mobility I've already kind of shown it. The goals involve certain things like reductions of hazards, but also a reduction of travel. But I focus more on the modal shift, so the reduction of car use and increasing of other modes, such as soft walking and cycling and public transport. The way the space is usually described, Poon already touched on this, is usually based on density, distance to city centre, and some very simple aggregate measures, and the concept that it started maybe 15 years ago as the 3Ds, but they've been expanding those 3Ds to include a few more things like destination accessibility and distance to transit are. So these are like the traditional measures that people calculate to describe these areas. And so if you describe them according to these, definitely the traditional city centre is very different from the other ones. And so they say, yes, those developments are failing because they don't comply with these principles. And so the model of the compact city or the transit-oriented development with very normative measures based on those principles, on those 5 dimensions, but starting to approach their interconnectedness, but to be honest, not really taking much care of what's the difference between being here, or there in the region. The model cannot be the same anywhere, or at least you can't expect it to work exactly the same by applying this same stamp in different places of the region. So this is the kind of thing I'm trying to explore. Indeed, if you look at this is the variation of the transit-oriented developments of the region based on those classic descriptors: population density, distance to city centre, land use mix, etc. And you'll see that there is very little variation between them, meaning that description is actually only capturing the difference between this is city centre and this is out of city centre. So it's not actually capturing this difference of being in different places in the region, not well enough. The only variation is actually in size, population size, and not really the other things. I'll come back to this one later on, because what we then observe is actually a very big variation in mobility between these places. So if you look at the amount of walking, cycling, transit use, so this I'm showing just a sample of transit-oriented developments. So in terms of actual mobility, what happens, in terms of empirical evidence, there is variation. They're not all the same. But if you measure them according to the conventional descriptions of density, land use mix, diversity, they're all the same. So how can we understand what is causing this kind of variation, if not the variables that led to their construction in the first place? So this is the things that triggered my research and the search for another model of measuring and describing these locations in the region. So around modality, this is also a diagram that started it, which is this notion of modality or mobility environments that Luca Bertolini has, that start describing there are environments with different profiles. But do all transit-oriented developments fall in this category or that category, or are they actually scattered? And that's what explains that variation in mobility. So it's not just about density, it can be about something else. And so what I decided to do is measure a richer set of descriptions of the urban areas that include those, plus some things more to do with accessibility and centrality. So this is just a summary of the categories of proximity, density, accessibility. In terms of proximity, it's proximity to certain network features that support each mode. So these all being multimodal, so proximity to transit, to walking infrastructure or cycling infrastructure, density of the network for each mode, the density of activities as well, and here we start entering more the regional structural configurational measures that we know, in terms of network centrality that we do a lot, but also activity accessibility, so the more conventional access to jobs, access to the retail. So I think rather than just focusing on 5 or 6 very simple measures, one needs to have a more broader, say, tool set of measures. And so that's what I set out to do, and start creating a model that allows me to describe in a high resolution and in covering the multiple modes of this region, trying to extract these measures. So a model that allows me to extract this rich set of measures. Data set, I've used OpenStreetMap data and some building data from the Netherlands to construct this model, and some public transport timetable data, and also some other sources. So this is the OpenStreetMap data plus some of the other data I just give you. And then the model resolution is at the street segment level, covering the cycleways and walking, pedestrianized areas, etc. It covers all the buildings and land uses in the region. And one thing that it becomes immediately clear is we usually just create one network, one layer of street network. The different modes all work different, so they kind of need different geographic representation, and they will also need some kind of different graph representation. And this is a distinction I make with my model, is to distinguish between the geographic representation of things and the graph representation of things. I think in space syntax it has always been the two concepts have been flat, because the map is the graph and the graph is the map. And here I start separating the two to give me more flexibility, because the modes are different, and so I wouldn't be able to find one representation to fit all purposes. So now to get to the tangible, the actual things, rather than leave the theory behind. So what I identify 3 systems. So it's a private transport system that's kind of consistent because it's based on the streets. The geographic representation is the conventional that you find in GIS, road center line representation with the nodes, junctions, and segments between them. This is, as I say, the geographic representation. The public transport I simplify just by linking stations between the lines. So there's a railway, it links to the next one and to the next one, and there's the land use sitting there in the buildings. But then I create another layer of linkages, which is I call the modal interfaces, to connect all these modes. Be it linking land users to the streets, this is linking public transport to the streets, linking public transport across between each other, and linking land users to the streets. So the streets actually becomes the skeleton, everything links to the streets. And so I create this model. So using these principles, I make the model for the region. This is just a zoom into the Amsterdam area. The whole model has, this is the geographic, I stress that geographic representation, 460,000 nodes and 6,000 segments, and a few million buildings. And I use some open source technologies to do this, because I'm kind of taking it to a different type of model. I can't really use existing tools from space syntax, for example. So I have to kind of make my own package of things. So let's have a look at, because I distinguished very clearly this is a geographic representation. Now, how do I actually measure accessibility, and how do I measure distance is the next question. How do I measure distance? So this geographic representation gets translated into a network graph. And here I take, for example, for the private system, private transport system, the thing that we do in space syntax, I'm using the street segment as the node rather than the intersection. That allows me to calculate things like the change of direction, and be it angle of change or number of changes, because in reality, if you use the node at the intersection, that thing doesn't exist, because you can only calculate time and length, the cost on the same. So that's the main reason why I use the node. On the other hand, the public transport, the node is the stop, and that gets linked to the street. So this is just a again, to stress that the graph and the geography don't necessarily need to match. So I said that the intersections were nodes in the geography, but that doesn't mean that your graph has to be with nodes at the intersections, no. So we kind of make the model for the purpose. It makes more sense and is consistent. So yeah, I'm just stressing the same point here. Geographic and graph is two different things. This allows me to actually calculate different types of distance. If I stick to one kind of model, the conventional, I could only do physical and temporal distance, but with using this thing, conversion to the graph, I can also do topological and cognitive. Here I distinguish the angular and directional. It's questionable maybe this distinction, but I just leave that. And so I say I also calculate, I use metric as well in temporal, so I get the average speed for each mode to assign it to the street segments. And the next question is, if you have the polylines of the street segments, how do you convert that to the topological distance? Because one thing I don't do as well is I don't generalize and simplify the street network. So what I do is calculate between the two intersections the amount of angular change or the amount of axial, for that matter, change by using things, principles similar to what the Lucas with his continuity lines does. So this is just in the paper it's clear. I mean, I'm not going to go into the details. But so what I'm doing here essentially is assigning to the different polylines that represent the street segments angular value, an axial value, continuity value, also a metric value. So the node gets assigned a value of all these types of distance. And also then for the transition that I mentioned, if you want to move from one node to the next, of course you get our axial gets one step. If it's angular, it gets some kind of angle between them. So this is just the distance that was calculated for each segment to go to the distance of the other segment to get half and add the cost of the turn, for example. If it's metric or temporal, the cost is 0 in this point. Anyway, so what I do here is calculate distance mathematically rather than changing the geography again, separating the geography from the graph. And so all the nodes in that graph get a range of distances that allow me to use them at the same time. And why is this necessary? Because I don't want to have, sorry, I actually mentioned here, I don't want to have alternative models or alternative graphs for each mode. I want to have one model that allows me to use the variety of things, the variety of modes. Just two kind of, not recommendations, but two conclusions in relation to this is that the multimodal distance, because the different modes have different speeds, the temporal distance has to be used when we want to do something like radius instead of metric. So that's a must, so I need to include temporal distance there. But as we've shown so many times, when we want to do pedestrian accessibility, actually the temporal or the metric is not necessarily a good predictor or descriptor, rather, of the structure. So we still might want or need to include cognitive and angular distance. So in this case, pedestrian and street movement you might consider the angular distance, and you combine it eventually with the topological distance of the use of the public transport. So some of the things I do with this model, so thinking back of that table of what can we measure or what do I want to measure to describe the neighborhoods, one of them is proximity, so we can just calculate the proximity, simple metric proximity to the nodes of the rail, the tram, the metro, the tram, and the buses. So this can give us sort of public transport proximity for the region, black holes of no public transport accessibility, bright spots of multimodal accessibility, other areas that only have one or other mode. So these values then are assigned to each and every neighborhood in the region. The other thing is that we do is the structural accessibility in the region. So in this case, this is analysis of the street car, private transport movement in the region, again using angular distance. Funnily enough, if I do the same removing the motorways, because I'm here doing the walking distance, it's actually absurd to do it at the global scale because no one really walks. And therefore it kind of gives a very weird concentration in the center. But if I check the public transport nodes and their centrality and combine it, because actually for pedestrians to move in the region, they move in a combination of public transport and pedestrians. So if we actually analyze both together, pedestrians and public transport, we start having actually a reasonable depiction of what is the centralities for the pedestrian and transit user in the region. That excludes precisely the motorways. So these kinds of things that the model allows, and I calculate all that stuff. Actually, here this is a summary of the various, I call it modality indicators that I calculate based on that table. So actually, I start with more than 1,000 things, but most of them are actually correlated with each other. So I go through a process of reduction that takes me just to 22 things that clearly and distinctively describe the different locations. Again, proximity, density, and centrality and accessibility, including access to work or transit access to work, car access to work, etc. And so going back to that picture where I showed the classic measures don't really distinguish the characteristics, the urban form characteristics of transit-oriented developments, taking these 22 measures that I've calculated, actually now we can see there's huge variation. So that variation in mobility that we hadn't observed before, so there was actually a variation in mobility despite no variation in urban form. When I saw this, I think, okay, now I can confidently say if I isolate the transit-oriented developments described according to these 22 indicators, I will be able to capture some of the conditions that might explain or might support that difference in mobility. Now, having come to this point with all these individual variables, I did what we all usually do, we just correlate things. And I'm not going to go into the details because this is not the end of the work. Yes, I got some correlations here and there, but actually this wasn't satisfying because yes, some areas have good, the cycle or the transit might correlate well with the fact that there's a lot of walking, but then something else doesn't happen there. So just looking at the correlations, because I have this rich set of descriptors that actually indicate that you can't really find just in one dimension, and having come from the statement that actually just looking at density, land use mix, etc., isolated doesn't explain, and as been shown, just looking at one thing doesn't explain the variation. I've decided to take a different approach, so this is something that I've shown actually at the last symposium. So if we just correlate, say, the centrality of the railway stations to the number of rail journeys, we see, yes, there is no straight line there. We might actually see this phenomenon, which is actually if there is no centrality, there is no. This is an outlier that I could explain at some other point. But if there is high, there is a potential, and this is one thing that we always argue as well. We're not explaining causality; eventually, we're showing potential. So the affordance of the area. So what I end up doing is actually clustering using a K-means algorithm the 22 indicators, and so what I create is a typology of neighborhoods in the region. So each neighborhood has a different type based on their profiles based on proximity and density and accessibility and centrality. So it's a composite description of each of these neighborhoods. And again, as you can see, patterns emerge, and clearly city centers being different from these. But also, if we were to isolate, I actually didn't put the slide here, if we were to isolate the transit-oriented developments, you would see that we'd have different typologies for them. So yes, from this clustering I can actually describe each of these neighborhoods. So we've got active multi-access cores, which are based on the density and the reach, they have particular characteristics. Again, I think it's better to read these descriptions in the paper rather than going through all of them in detail. So this is just a semantic description of what each of those types are based on the indicators that describe the region. So for me, what these do is give a profile of each of those neighborhoods and a composite profile. So there's a typology. And now if we go back to mapping those typologies to mobility, we see that there is a clear pattern as well. So certain types correspond to various, so each chart is showing the level of walking, cycling, car use, transit use, and other things related to, actually, I'm saying it all wrong now. Yeah, I'm saying it all wrong. This is walking, cycling, car use, transit, train, and this bit is like mean distance and mean time of travel. So the areas that are most in the city center have a certain profile, other areas have different profiles of mobility. So there is a relation. So rather than looking for a correlation, I'm looking for a relation that shows that if we build certain types based on this big set of variables, we can expect a certain potential use. So if we look at transit-oriented developments described according to those types, if we have a transit-oriented development that falls here, or here, or here, it's not just about density, it's this combination of descriptions, because they have these different types. We can expect also different types of mobility in each of them, so that it would explain the variation. And to do this quantitatively rather than just visually, if we correlate, not correlate, if we relate so each of these charts represents one mobility parameters, like walking, and here vertically, horizontally we have each of the typologies. So the colors just indicate the p-value, the significance of each of the mobility performance to each of those types. So if we find very dark blue means a high significance of, for example, in this case, train use in types 1 and 2, average train use in type 6, and there's no significant relation to the other types. So if we look at the neighborhoods based on these typologies and based on the different profiles, we start understanding that it's a very complex and composite set of criteria, really, that show what I'm, because I don't give a single number. That's one thing I'm trying to avoid here. It's really showing profiles and potentials, showing charts and quantities that give you an indication of how much you can expect, rather than this is going to be the value. This is still, my supervisor isn't here, so I can say this is still work in progress. Otherwise, I would have been told off. But this is going to be my final stage of the work. Is bleeding from here, so I still need to work more with this final stage to come to more clear conclusions about how to summarize this into. And I'm going to definitely in the conclusion of the work then focus on those transit-oriented developments. So here I'm giving the big picture of all the types and all the characteristics. I'm not going to go through all this again. I think I've run out of time. But yeah, this for me the important thing is looking for a model that can describe.
The next speaker is sick. I will present for him, but
okay.
This
fine.
You use the time you need because.
Okay, but I don't think the time is the conclusions. It's my last slide anyway. Thank you. But let me just. I'll just sneak on me. So. Point number one, I think the whole point of this model that I've created, which is actually quite complicated, I still ask myself, does it have to be so complicated? This is a question that I leave. But definitely one thing I think it needs to be multimodal, because that's the reality that we need to address if we're talking about mobility and sustainable mobility. It's all about modes of movement, and so we need to address this. And it is about city regions, because things don't sit isolated, they sit in the context of a region, and if we just describe them very simply, we won't capture their nature. Another thing I've stressed is this separation that helped me create the model between the geography and the graph. Otherwise I wouldn't be able to come up with a model that I think is relatively robust. And I didn't explore this aspect, but using multiple concepts of distance in the same model, in another paper I'm working on, actually allows us to actually compare the same case with the same model using different concepts of distance. Quite often we see these debates about, oh, this measure is better than the other, but applied to different places with different models and different cases. And having this model that actually covers a wide range of things allows more comparative studies. Now to the topic itself, it reveals structures and hierarchies of modality, profiles of modality in the region. So identifies these, using this reduced set of modality indicators, I'm able to describe in a richer detail, as we've seen with the variation of transit-oriented development. We can actually see in richer detail what are the characteristics of each urban area. And although we can confirm some of the urban-form principles of sustainable mobility with this, more importantly to me, is that we identify those modality profiles. So we don't reduce it to numbers, but to complex profiles that describe each area. So yeah, and hopefully in the end I will come up with some more clearer method of doing this. Essentially the goal is to measure the potential that each neighborhood can afford. Not saying that it will do it, but what do the different transit-oriented developments offer that leads to this variation in mobility. So that's my ultimate goal.